Welcome to the Industrial IoT Spotlight, your number one spot for insight from industrial IoT thought leaders who are transforming businesses today. With your host, Eric Walenza.
Welcome back to the Industrial IoT Spotlight podcast. I'm your host, Eric Walenza, CEO of IoT ONE, the consultancy that specializes in supporting digital transformation of operations and businesses. Our guest today is Yonatan Geifman, co-founder and CEO of Deci. Deci provides a proprietary optimisation technology for deep learning practitioners that enables you to accelerate deep neural network interfacing on any hardware while preserving accuracy. In this talk, we discuss new technologies that enable AI developers to build, optimize, and deploy faster and more accurate models for any environment from the cloud to the edge. We also explored the development processes that commonly lead to long delays in deployment and unexpected costs when migrating from a development environment to an operating environment. If you find these conversations valuable, please leave us a comment and a 5-star review. And if you'd like to share your company's story or recommend a speaker, please email us at team@iotone.com. Finally, if you have an IoT research, strategy, or training initiative that you'd like to discuss, you can email me directly at eric.walenza@iotone.com. Thank you.
Yonatan, thank you for taking the time to speak with me today.
Sure, thank you for having me. Nice to meet you.
So I'm looking forward to the conversation here. I think we're probably going to go into some topics where I may be struggling to keep up with you. So personally looking forward to educating myself a bit about deep learning. But first, maybe you can give us a bit of background on yourself and how you ended up founding Deci. I know you have a PhD. Was this idea kind of originated in your studies there, or what's the origination story behind the company?
2 years ago, I've completed my PhD in computer science, focused on deep learning technology. During my PhD, I studied and researched areas of making deep learning technology more applicable for real-life applications, and specifically worked on the problem of uncertainty estimation, which is how can you estimate the confidence or the uncertainty of a machine learning, a deep learning model in its predictions. Based on that research, we explore the barriers of taking AI to production in industry or using AI in various types of applications, where one of them is what we focused on my PhD. Another area that we found out that is very interesting is the computational complexity of those algorithms and how can we make them production ready in their performance aspects to be easily deployed on any environment in a scalable fashion. So after completing my PhD, together with my PhD advisor, Professor Anel Yaniv, and another co-founder more focused on the business side called Jonathan Elial, we started Deci in a mission to break the AI barrier and make it deep learning technology being accessible and being able to be deployed on any environment, anywhere, in any scale. And we're doing it by automating the process of finding the structure of the model or developing the model in an autonomous fashion, where the performance is one of the key differentiators that we believe that has to be taken into account in the early days of the development. But maybe first let's understand a little bit more about how deep learning development life cycle looks today. Today it starts from a data scientist or a deep learning developer that is working in a lab and has to solve some business problem or product problem. For example, detecting some objects in models. He explores some academic papers and some GitHub repositories and find out a model that is good to solve the problem. And after he or she solves the problem, they found out that it's not so easy to take that model that they solved in the lab to production because of many, many reasons. But one of them is that about half of the algorithms are working in the edge. And in the edge, there is limited computational power and and compute that has to be taken into account in the design stage of the algorithm. And what Deci gives is a development platform that enable data scientists to build algorithms that already take into account all the production constraints and characteristics in the development cycle, and by that shortening the endless iterations of making the algorithm production ready to be deployed anywhere.
Okay, so maybe a more traditional approach might be that you develop the algorithm on the cloud using more or less unlimited resources. You find a model that basically works in that environment, and then you try to deploy that in the real world, and you hit these constraints, and then you have to kind of rethink how the algorithm is built, and that drives a lot of time and effort. Is that kind of the problem that you're solving? Is avoiding that rework?
Yeah, actually, this comes with endless iterations between the development environment in the cloud and the production environment at the edge, trying to build something in the cloud that will fit the edge device that you want to deploy this algorithm on, and simply takes a lot of time because each iteration requires a new training of a new model that takes a lot of time and a lot of resources, and this is a huge problem to solve.
Gotcha. And so here we're talking about solving problems that are on the, deployed on the edge. So I guess we're not talking about probably fintech or e-commerce problems. We're talking about, what is this, manufacturing? Is this energy utilities? What would be the key industries where your customers are coming from?
Yes, absolutely. Manufacturing, smart city applications, autonomous vehicles. Most of the AI algorithms that are deployed in the edge are related to deep learning. Also, we have healthcare related use cases to run computer vision at the edge, and many other industries and use case. Also, mobile applications, video analytics solutions, and many more.
So you mentioned already a couple of use cases. You mentioned video and machine vision, which I guess could, highly related. So that's obviously a huge class of use cases, anything related to vision. So this is always a question for me about platforms: is to what extent does it make sense, to build a general purpose platform that can, versus maybe a platform specialized around a particular use case. From a technical standpoint, is there a benefit in saying this platform is optimized for machine vision, for example? Are the underlying quantitative challenges similar enough between different types of problems that it doesn't actually make sense to focus on a particular type of use case?
That is a very good question that we ask ourselves every day. I think that there is a range that each and every solution need to define its sweet spot between the platform, how much the platform is easy to be customized for various use cases, and on the other hand, how much it is being easy to use. If you try to build kind of the dream of the AutoML and no-code platform, yeah, you will probably have to start with something that is very narrow use case that can be supported on that platform. But if you're looking to something that is code-based, that is an SDK, that could be easily extended into more use cases, and even giving your developers or your users to build upon your tools in order to build new use cases and expand from your initial focus target use cases. And this is exactly what we are doing at Deci. We're providing developers tools that our users and customers can build on top of them any type of neural network, any type of use case. What we do focus on is deep learning technology. So we are working on neural networks. Either it could be for computer vision or NLP. Maybe in the future we'll have some audio processing use cases. But this is roughly all the aspects where deep learning dominates today.
Gotcha. Okay, so if we can consider that you're taking this, let's say, call it an SDK approach, where people are building custom solutions on top of your platform, the users then would they be data scientists, or what type of technical background would a user need to have in order to, I guess you could look at this first for building the algorithm, and then second is maybe optimizing the algorithm once it's in deployment. But what would be the typical profiles for users?
Yeah, so we're providing tools for the data scientists. We, at the moment, we are not trying to reach new audiences, like to make any software engineer being able to build deep learning solutions. We're targeting the data scientists and helping them build better solutions than what they can achieve with the standard tools that they're using today. In terms of the personas or the people that are using our platform, it starts from the data scientist. After they have a data set and they want to build a model, they use our tools to build models based on one of the models that we provide in our platform. We call those models DeciNets. DeciNets are models that are known for their good performance, both in terms of accuracy and latency. For each and every hardware, we have a different DeciNet and task. And the second persona is kind of the machine learning engineer or even the DevOps at some use cases that have to take this algorithm and take them into production. And sometimes we're getting the machine learning engineer to approach to us and ask, okay, how can I make this algorithm to run on this specific device in this and that latency? And sometimes the data scientists understand that their work is not only to provide the best accuracy, but also to provide a model that is production ready in the essence of feasible to run on the device that the company is trying to deploy it on.
Yeah, there's another problem that actually we're bumping our head against right now, and maybe I can pick your brain on this. It's the problem of scalability. So let's say you develop an algorithm for a particular motor on a production line to determine when it might break down, and that algorithm works, it's production ready for that motor. But then, of course, you've put in a lot of effort to build that algorithm, and you want to now scale this to 20 other production lines, and then you also want to scale it to other factories. And maybe the other production lines have sensors from different manufacturers. They have, so the data inputs are somewhat different. So the question then is, to what extent is that algorithm that you've built scalable to similar situations that are maybe not 100% identical in terms of the data inputs or the environmental conditions? Because if you can't kind of cut and paste that algorithm, the R&D cost is too expensive to replicate. So do you have any thoughts on, is this, let's say first, maybe is this one of the value propositions that you're bringing? And then do you have thoughts on how to approach this problem of scalability of an algorithm across multiple assets in maybe similar but not identical environments?
I totally agree with you about the problem of scaling those algorithms for various types of use case with different data sets. Some of our customers, especially an example in the retail space, has to train a different model for each and every customer they're deployed on. And based on that, one of the properties that is very important for them is let's call it the robustness of the model and the training of the model to different types of data and data sets. And this is something that we pay attention very highly, that our algorithms that automatically design the models are not converging to some very, very specific point where it suits only one use case, but providing a general purpose algorithms that are good for many types of data sets and many types of problems. So this is something we pay attention to. And I think that it's a very important property of a model to be able to generalize good for different types of data sets and tasks. Because if that won't be happen, the algorithm will just, it's kind of show it's affect the lifetime of the algorithm, because it will break with the first distributional shift or dataset change that will occur in the production environment. And we need the ability to retrain models and adapt them as an ongoing process to the production environment and the changes that we see in the use case and in the product.
Okay, interesting. So then let's say you could optimize, let's say the perfect algorithm for a particular situation, but it's better to have an algorithm that's maybe not perfect for that situation, but that's more adaptable to similar situations. I guess one good example here is Zillow, which is maybe not, it's certainly cloud-based, but are you familiar with the company Zillow, this real estate?
Yeah, absolutely.
So they just killed their business, right? And it seems to be that their algorithm was optimized for market conditions that have changed very much this year. and it can't adapt to the new market conditions. At least that's kind of my reading of what happened. Do you have any thoughts on why all of a sudden they closed down this business, and why they were unable to adapt to the market conditions?
I don't want to try to predict what happened, particularly in that use case on Zillow, but generally speaking, I can tell that I believe that problems like this are coming from the world of distributional shift, where algorithms are trained at some point and deployed to production. And we need to have the tools and the methods to track them, to track their performance in production, and understand that something has been changed and the algorithm needs to retrain to build from scratch or something like that. And this is a phenomenon where the lifetime of algorithms that are running in production is sometimes limited and had to be monitored all the time in order to catch those changes in the market or the environment that affect the algorithms to provide poor performance, and then they need to be retrained for and more updated data sets or maybe replaced.
Gotcha. Okay. So I want to dig into more your solution and also the topic of deep learning. But before we get more into the technical details, on the business side, I'm actually very curious. What are the KPIs that you are promising or presenting to your customers when you're making the case that your solution is the best solution? So is it reducing the time to deployment? Is it reducing the number of data science hours? Or because what's the mindset of the buyer here in terms of the aspects of production that they're trying to optimize around, from a business standpoint?
So we are selling performance. When I'm saying performance, I'm referring to accuracy of models. So on our platform, data scientists can build models that are more accurate. Or the other side of performance is models that are running faster for being more scalable or can run in real time. Those are kind of the KPIs that we usually engage with customer with. Obviously, getting that performance levels is something that will take an experienced data science team much more time to develop, and sometimes they will not be able to reach that level of performance at all. So yes, in one aspect, the business value proposition is the time to production, but it comes from a performance standpoint that there is a gap between what the data scientist or the data science team has been able to get to the point where we start the engagement and what is needed in order to get to production. Usually it comes with a very tight deadline for going to production in the next version. And we show them how they can build on our platform similar algorithms or optimize their existing algorithms and get better accuracy or better latency in order to make the models production ready.
Yeah. Okay. Makes sense. And this data scientists are, I would say, right now a very constrained resource. I don't know of many companies aside from the kind of the internet giants and maybe some well bankrolled startups who are rich in data scientists, right? Everybody seems to be, they've got a small team, a couple people that have way more workload than they can handle. And then you deploy something. And then, of course, you also have to maintain it. So then you're both building new products and you're maintaining existing products. Do you see us, you can look at this regionally, you can look at this globally. Maybe if we just look at it globally, do you see us moving towards a world in the next few years where the supply demand of data scientists is more equalizing? Or do you think that we're going to be in this situation where demand is kind of greatly outpacing supply of data scientists for the foreseeable future? Because for me, that seems to be our clients all have a huge constraint there of a lot more ideas than they have talent to execute on those.
So I think that this problem relates to sub-problems. One of them is the total number of data scientists that we have in the world. And the second thing is the productivity of the current data scientists. I think that we'll have much more data scientists, but they will be definitely less experienced than those we have today, or those that today already doing data science and how they will be experienced in 2 years. So the overall experience or average experience of the data science community is getting lower and lower because new data scientists are entering the field in masses every year. On the other hand, we see a lot of tools and platforms that try to help the data scientist reach their goal in shorter times. So I think that data scientists will be much more productive, and also the proficiency that will be needed from data scientists to solve, let's say, 80% of the problem will be reduced significantly with those tools. So I see two vectors that are working together in order to getting us to a better standpoint in terms of the need or for data scientists that we see today at industry. So yes, I believe that in 2 years we'll have better tools for data scientists and they will be more productive in that sense. And also the proficiency gap will be reduced a little bit because of the tools that will automate and standardize some of the work of the data scientist. And the second half of it, that we'll see more and more data scientists, as a lot of people are now going to study in universities and courses to study data science in order to enter that field as they see it as a very promising field that is exploding at the moment.
Gotcha. Okay, so we'll have more people in the field, but less experience, and then tools to help them nonetheless be effective. Let's dive in now to the platform, the Deci platform. Maybe we can start just from a higher level. What is the work to be done? So I like how you've broken this down here into build, optimize, and deploy. And I think some of our listeners are quite familiar with the process of building algorithms. Some are probably not familiar at all. So it might be a useful starting point just to talk through the process of building an algorithm and what are the challenges along that process.
Sure. So as you mentioned, the three components of the platform is the build, optimize, and deploy. Let's start from the build. Build is basically an SDK for data scientists to build on-premise and train deep learning models based on well-known neural architectures and model templates, or based on Deci's starting point for algorithms that we call DeciNets. So it enables the data scientists to build faster and streamline all the process of training the model, selecting the hyperparameters and the neural architecture. And it comes right after they have an initial data set to start to work on the problem. So a data scientist that has a data set and want to start experimenting and try and find a model to get to the accuracy level or to get to the performance level that is needed, should definitely start and explore using our build component of our platform. Once we are getting to a model that is reaching the levels of accuracy that we can think about taking to production, we need to skip to the optimize stage, which is kind of the pre-production of the machine learning model, where in this stage we are applying some techniques such as compilation, quantization, in order to squeeze the algorithm and kind of pack it to be ready to go to production, which leads us to the latest stage, which is the deploy, where there we have two tools. One of them is SDK based and the second one is containerized, to take the model and do the serving in the production environment. So this is SDKs that used usually by the machine learning engineer in order to take the model that the data scientists have been built and run them in the production environment, either connect them to the application or deploy them as a microservice in the cloud.
Okay, so the optimize is not so much about optimizing the performance of the algorithm, but it's optimizing the algorithm in order to perform on, let's say, constrained compute on the edge. And then what would be the limit for, I guess this depends on the algorithm, but what's the typical lower limit for processing power, or maybe memory on an edge computer in order to be able to run one of your algorithms?
So it really depends on the use case. If you want to run computer vision on video, it's not similar to running some NLP applications. So it really depends on the use case and the model that is needed in order to solve the use case. The interesting fact is that we are providing a set of algorithms that can be used on our platform that is ranging from the very lightweight algorithm that can run on almost any hardware. It could be i5 CPU running in real time, to more complex algorithms that reach very good accuracy that can be run on more advanced AI dedicated hardware. So we can consider it as something that we call an efficient frontier, a trade-off between accuracy and latency, which is kind of a curve that you can choose on that trade-off, the sweet spot that is defined by the hardware that you're trying to use in production and the level of accuracy that you're interested to get. So if you will take a specific example, we can think about the virtual background application in video conference, the virtual background feature in video conference. I believe that everyone is familiar with that feature that we can see on Zoom and Microsoft Teams and all those applications that kind of blur the background or remove it with an image. On that use case, a computer vision algorithm that is called semantic segmentation has to be running in real time on the edge device, on the laptop of the user. And in order to do that, you need the algorithm to be very fast. One of the ways to make it run faster is to reduce the image resolution and work on small images, but then the details of the segmentation won't be good, and the result will not be so good. And what Deci is doing with our customer in that use case is accelerating the performance that this model will be able to run on the highest resolution with the highest accuracy on a real-time performance of 30 frames per second in order to give the real-time experience of that feature of the virtual background, but also gaining the best accuracy. And as I mentioned, there is kind of a trade-off between running fast and running accurate, and Deci helped to exploit that trade-off and choose the best sweet spot that is available, that is significantly better than any off-the-shelf algorithm that can be used by academic paper or a GitHub repository.
Gotcha. Okay, interesting. And then your core technology, I guess you're probably using a lot of open source solutions, I would imagine. And then you have this automated neural architecture construction, the AutoNAC technology. Can you talk a little bit about how you make this happen? What is the underlying tech stack look for, Deci?
Yeah, absolutely. AutoNAC is an algorithm from a family that is called neural architecture search. It's a family of algorithms that is started from Google in 2017 that automatically design or search for the best structure of the neural network for a given use case. And when I'm saying a use case, I'm talking about the data set on one hand and the hardware that we're using to run the algorithm in production on the other hand. And what AutoNAC is doing is kind of being able to solve an optimization problem that is finding the fastest model or the best performing model for a given use case and a given data set that is reaching a specific level of accuracy. It is kind of solving a constraint optimization of finding the structure of the neural network in a search space of hundreds of thousands of candidate neural architectures that solve the problem of finding the sweet spot of performance between latency and accuracy for a given data set and use case.
Can I think about this basically as an engine that is testing hundreds of thousands of different structures and then testing them against each other, and then kind of determining which structures fit the use case best? Is that kind of the output of the engine?
Yes, absolutely. That's what AutoNAC is doing with one caveat, that searching exhaustively in that search space is impossible, because to test a candidate model out of that search space, the model needs to be trained with the data set in order to get what will be the accuracy of that model. And this could take days of GPUs. So we cannot explore the entire search space and take each and every model and train it and do, let's call it the classical model selection problem. We have to use more clever techniques in order to estimate to estimate the accuracy, the resulting accuracy of a given model on a given data set without training it. And this is what differentiates Deci's AutoNAC from other neural architecture search algorithms that invented in Google or in companies that have huge amount of compute. And Deci's AutoNAC is working in 2 orders of magnitude faster for convergence compared to any existing neural architecture search algorithm, making it the only solution that is commercially viable for using by companies in order to optimize their specific use cases and problems.
Okay, very interesting. So, what would be? I guess this depends a lot on the use case, but what would be a runtime here? You plug in the data set, begin training. Are we talking about minutes? Are we talking about hours? Are we talking about days to optimize or identify the most efficient path?
So in matter of days, actually, it's a function of the training time of the model. Usually, it takes 3x to optimize 3x of the training time to optimize a model with AutoNAC. Usually, it ends up with a few days of convergence for the search algorithm, which is relatively very good because doing it manually by trial and error iteration by a data scientist is taking much more time and is not guaranteed to converge to a result as AutoNAC can converge by searching cleverly in such a huge neural architecture search space.
Gotcha. Okay, interesting. And then there's another significant pain point up front, which is making sure that the data that you're putting in is actually, good data. I think that's one of the more significant, just very practical pain points in this process. So that means pruning the data. It means also tagging and so forth. Is it generally that this would have to be done on a different platform and then high quality data uploaded into your platform, or do you also cover that within the scope of the of Deci?
So we usually engage with customers that already have a large enough data set that is labeled and ready for training the model. We are focusing on the model stage in the development lifecycle. And data labeling or tagging is not something that we are dealing with at the moment, but it's a future direction that we might approach later on.
Gotcha. Yeah. I guess there's certainly tools for this. It's just a very labor intensive process. I think there's here in China some companies I know that just have 10,000 people sitting in some city somewhere in the center of the country, tagging data for clients, right? So
yeah,
the pricing of the solution, it's basically sold as a SaaS, is that right? And then would that be around the number of users, or it's around runtime, or how would this type of engine actually be priced?
So it's a SaaS, it's a subscription to a SaaS platform that is priced by the number of models actually. So we want all the organization, all the data scientists to be able to work with our tools, and we don't limit the number of users or anything like that. But the subscription is based on the number of models that are being developed on the platform. Usually small companies have something between 1 to 5, maybe 10 models, and larger companies have something that is from 20 to 50. And this is usually the currency that we use in our subscription for the platform.
Gotcha. And from yours, is there any difference in I imagine models require different amounts of compute power. So from your standpoint, is there difference in cost if somebody's running a small model versus a high? Is that kind of impact your OpEx, or is that more or less inconsequential?
So actually the training and the optimization is running on the customer cloud or data center. So it does not affect not our costs and not our pricing. So the answer is no.
Okay, so that's just something that they have to account for. Okay, great. Well, maybe you can walk us through one or two cases end to end. Just looking at where's the company coming from, what problem are they solving, and then walking us through the deployment path.
So one of the use cases that we've seen from a company that is developing a smart city application that detects trash in the cities based on smart cameras that are deployed and running with computer vision compute attached to them. And what we've seen is a company that is struggling for making the algorithms run fast enough in order to get good enough performance and accuracy from the end-to-end application. And what we have done there, we let them develop an algorithm on our platform that is running faster and is more dedicated to the hardware that they're using in their production environment. After they trained a model based on their data and in our platform, they use the quantization and compilation techniques that are integrated in our platform and deployed it based on the deployment SDK that we are providing in the edge device. And the overall experience that they have seen is running from a model that is running in 1 frame per second on that hardware device to a model that is running about 12 frames per second. So it was a 12x boost in latency that enabled them to run this algorithm on the specific hardware that they chose or the candidate hardware that they considered for that application in a good enough performance in order to that the algorithm will run the application and will collect the data that is needed for the application itself. So this is one example of a smart city application. Another example is a mobile app for image processing that is deployed on mobile devices. And on some mobile devices, especially Android-based devices, the performance of the computer vision module in that application was not running fast enough in order to give the good experience on the device. It was draining the battery and taking too much to compute and incur latency in the user experience of the application. And that company were using a cloud compute in order to do that specific model computation. So they had an image on the mobile device, they sent it to the cloud, did the processing, the image processing of that specific use case in the application of that specific module in the cloud, and then sent back the results to the device and presented it to the user. This was problematic from 3 aspects. One of them is the user experience. The user has to wait for a few seconds in order to get a response from the cloud. The second thing is a security issue where the data, the personal data of the customer that is being processed is sent to the cloud and processed in the cloud and being in transit. And the third thing is the cloud compute, the cost that is related to that application that has millions of users every day. So by using the Deci platform, that company was able to rebuild the algorithm behind that module and make it edge production ready and push it to the edge to work on a wide range of devices and making the algorithm run in real time on the device, eliminating all the complexities of sending images to the cloud, running deep learning computation in the cloud and sending things back. And that was a huge gain for that company, that now their mobile application is running significantly better and reducing the cogs associated with that module in the application.
Okay, yeah, quite interesting. I think a lot of people don't actually think about the applications that they're running on the phone and where that processing is done and cost of transmitting data and so forth. But obviously, this can be quite considerable. For the first use case, this was, you said, smart city and around trash. Do you know what hardware? I mean, were these on garbage collection endpoints? Were these on trucks? Do you happen to know kind of the operating environment that one was in?
This deal was led with one of our hardware OEMs partners. We recently announced a partnership with HPE, and this specific use case was on HPE box edge server that is running on a CPU. So the main task here was to make a model running on CPU feasible to run on real time, as you mentioned, on a track that is moving all the time. And the high frame per second was needed because of the movement of the garbage collection trucks.
Yeah, it looks like there's a great new generation of hardware coming out to make learning work a bit better. I see a lot of also entrepreneurs working on this problem as well as the big players like HP.
There's something to understand that it's kind of a question of supply and demand. There is supply for new chips that can process better and run faster, but the demand is also growing exponentially and even faster than the progress in the chip industry. As we hear all the time on new models that are more complex and larger, like GPT-3, and also new models after GPT-3 that are even larger. So it's kind of a supply and demand question, that there is always a gap between what the data scientists and the people that are building the application want in terms of compute and what the hardware can bring them at this specific time. And we believe that this gap will exist for at least the next 10 years, because the progress in hardware is kind of limited by Moore's law, but the progress in algorithms is going exponentially all the time, and we can see it by the huge language model or by the use of transformers for computer vision and many other vectors that we see at academia that make models just be bigger and more hungry for compute.
Yeah, no, you're right. This is a really interesting problem space because it's very much an ecosystem, approach, right? Where you have improvement in the underlying algorithms, you have in the processors, in the modeling approaches, just the physical hardware. So you have these, also in connectivity and bandwidth costs. So you have improvements in a lot of different areas that all kind of feed on each other. And then there's, of course, some areas that are moving significantly faster and others slower. And then you have also the very human element of how do you aggregate the resources to perform this? What does the partnership strategy look like for Deci? Who are you working with? I mean, obviously HPE is one of these partners, but who else are you working with in order to make sure that you're part of, let's say, a winning ecosystem? Because I think that's probably quite important in this business.
Absolutely. So we at the moment have three types of partnerships. One of them is the hardware manufacturers. For example, we announced a partnership with Intel. This is both technological partnership to develop models that are dedicated for their types of hardware and doing research together, and technological aspects with what is called Intel Labs. And the second thing there is the go-to-market partnership with Intel, where we are working with their sales organization to identify opportunities for Intel customers that are trying to use deep learning models on Intel hardware, and how Deci can help them make Intel hardware more scalable and running deep learning algorithms on that. The second thing is the OEMs. OEMs are usually those who interact with customers that are trying to build data centers for deep learning, or to build edge servers for deep learning. And those are kind of facing the computational limitation of their solutions in front of the applications that their customers are trying to run on that. So by partnering with HPE, we're getting opportunities from their sales organization of use cases that are running computer vision at the edge or in the data center, in order to accelerate those models and make the algorithms ready to run on the hardware and solutions that HP is selling. The third part is the cloud area, where we partnered with AWS in order to make our solution available in the AWS marketplace and enable AWS users and customers to build more scalable solution with with better economics and lower cost to serve in the cloud. So these are kind of the three. We are seeing some other partnerships coming up, but it's still a little bit early to announce on them, and other direction for the partnerships that we are exploring at the moment. But these are kind of the main three partnerships that we formed already and already bringing customers to Deci.
Okay, great. Yeah, I think this is from our standpoint increasingly important here. Yonatan, I think we've covered a fair bit of territory here. Anything important that we haven't touched on yet?
We didn't talk about a very interesting research aspect that we've done recently at Deci. Actually, at Deci, we recently broke the state-of-the-art performance for deep learning in a family of neural networks that we called DeciNets. This was announced in our website and also in the press, and algorithms that are breaking the trade-off, the known trade-off between accuracy and latency to a new frontier. For example, classification models that are running on 2x reduction in latency compared to existing open source and algorithms that we announced. DeciNets is now offered on our platform and can be used by data scientists in order to build more accurate models or models that are running faster in production. And this is very interesting, actually, being able to use the AutoNAC technology to generate models that are at some sense general purpose and can be used by customers in a self-serve fashion for their application to run better or faster.
Okay, interesting. Was this done independently by yourself, or you were doing this with a partner or a university lab, or you're?
So actually, we have a research team here at Deci with 3 professors on board and a few more PhDs. And this result of DeciNet was kind of a direct result of applying the AutoNAC technology on some well-known benchmark data sets and models and getting kind of a result that is competitive to any existing known model that is usually used at industry. So this result was internal, but now we are providing users and customers to leverage those DeciNets for their applications. And it's very interesting to see what are the use cases that people are using those DeciNets in their early days.
Yeah. Okay, fascinating. Yeah, it's such an interesting space because every year there's records being broken. There's somebody's coming out and kind of moving the ball forward. What do you see on the horizon for Deci? Any if we look towards 2022, what are the big focus areas for you?
So I think that the focus is about making our tools more accessible for even less experienced data scientists or software engineers. So something we are thinking about is how can we make our platform more accessible for everyone. One of the direction is to provide an open source in the space, help use some of the components of our platform for free. Another directions is how to make the API easier for using and applying to the standard problems in computer vision and NLP, and making everything more accessible for less experienced data scientists.
Yeah, that seems reasonable. I think this is probably one of the big areas of innovation that a lot of our clients need, right? Because they don't. It's hard for industry to hire really experienced data scientists, right? It's hard to compete with Google and Alibaba and the big players out there for top talent. So you end up hiring younger people, or you end up training your existing team to run, and they need then tools that they can use effectively. Great. What is the best way for people to either reach out to you or more generally to learn more about Deci?
We have a SaaS platform that is open. User can just sign up and try some of the things that we provide on the SaaS platform for free. That will give a good sense about some parts of our offering. And the second option is just to book a demo in our website, and someone will get back to them and we'll do a demonstration of the entire capabilities of our platform. So this is kind of the best way to see what Deci can deliver to any use case.
Great. Yeah, we'll put the website in the show notes, but for folks that are listening, it's Deci is DECI.ai. So there you can sign up, you can book a demo. Great. Yonatan, thank you for taking the time today.
Thank you very much. It was a pleasure.
Thanks for tuning into another edition of the IoT Spotlight podcast. If you find these conversations valuable, please leave us a comment and a 5-star review. And if you'd like to share your company's story or recommend a speaker, please email us at team@iotone.com. Finally, if you have an IoT research, strategy, or training initiative that you would like to discuss, you can email me directly at erik.walenza@iotone.com. Thank you.